Welcome to algebraic fractions. Sorry, I'm being pretty quiet. There's a class in the room next to me. Hey, have a look at the syllabus reference. That's the first thing I want to draw your attention to. Manipulate complex algebraic expressions involving algebraic fractions. This is the kind of first thing that we've done this year that's actually on the syllabus. So this is quite an important thing. I would be taking my notes really well. You'll probably want to use the notes in the textbook that resemble this. Worked examples, there's questions in the textbook that you find particularly difficult, using them to guide your notes. But first of all, let's have a look at adding and subtracting algebraic fractions. Now, I just want to run through a really quick reminder of how to add normal fractions. So if I, for example, had 1 on 2 take 1 on 3, I need the bottom numbers to be the same. So take 1 on 3. So I'm going to multiply these by things to get them to the same number. Now, what's the lowest common denominator, lowest common factor, lowest common multiple, thank you, of 2 and 3. Easiest way to do it if you get stuck with these is just times them together. So 2 times 3, don't forget, what I do to the bottom, I have to do the top. 2 times 2. So this question has actually then become, well, 1 times 3 is 3, 2 times 3 is 6, minus 1 times 2 is 2, 3 times 2 is 6. Now that I've got them the same, I can then put the tops together and just have the bottom. So I'm just going to have it over 6 because it's over 6 on both of them, which means I can just do 3 minus 2. And this is extension math. This is advanced mathematics, so I expect you to put this in your calculator. 1 on 6. What we're doing is a version of this, but it's going to instead involve algebra, because, like, why not? Let's try and get rid of these. This is not an easy process. Okay, maybe I'm just going to leave that in. On 2 minus. Okay, so I'm just going to leave that in. Now let's try example A, which is x on 2 minus x on 3. So the question itself was x on 2 minus x on 3. Now the only difference between this and the one we just did was instead of 1s we've got x's. But we're still going to have x on 2, x on 3. We still want the same numbers on the bottom. We want the lowest common multiple on the bottom. We want a common denominator. So I'm going to times that 2 by 3, which means I also have to times that x by 3. 3 by 2, which means I also have to do the x by 2. Now I'm ending up with 6 on the bottom for both. X times 3 is 3x. X times 2 is 2x. Now I can put them together. You may not even need to write that whole second step, 3x take 2x. You may go straight to this one. 3x take 2x. You may go straight to putting them together, that's fine. And that's 1x over 6. Let's have a look at the next example, which was, actually, why am I looking there? I've got a textbook right next to me. We've got 5x on 6 plus 11x on 4. Wow, this kicks up really quickly. Plus 11x on 4. Wish I'd done that in black to be consistent. That's really annoying. Okay, so I need a lowest common multiple. I need the common denominator. So what's the smallest thing that's in both the 6 and 4 times tables? Now, if you want, you can just times the 6 by 4 and the 4 by 6 and have 24 on the bottom of both. You'll have to simplify at the end. It's easier to just go through the larger ones times tables, so the 6 times tables, until you get something that 4 goes into. So 6 ones are 6, 4 does not go into 6 evenly. 6 twos are 12, yes, 4 goes into 12. So I'm going to aim for 12 on the bottom of both. What do I need to times 6 by to get to 12? 2. What do I need to times 4 by to get to 12? 3. Which means I'm going to end up with 5x times 2 is 10x. 11x times 3, that's 33x. I've got a common denominator. And I can do 10x plus 33x. Honestly, I wouldn't do both this line of working out and this line of working out. I'd either do this one or this one and then go straight to the answer, which is 43x on 12. Next question, 2 over 3x, take 3 over 5x. So we've got 2 over 3x subtracting 3 over 5x. Now what's the difficulty here? We have x's on the bottom. We're still going to aim for the same thing on the bottom of both fractions. The x's are already on the bottom, so we don't need to worry about the x's that much. We do need to worry about the 3 and 5. Let's go through our 5 times tables. 5, no, 10, no, 15, yes. So we're going to end up with, we've got our 2 over 3x, 3 over 5x, and we're going to end up, we want 15 on the bottom, so I'm going to have to times 3x by 15x on the bottom, sorry. So I'm going to have to times that by 5. 15x on the bottom times this by 3. And we're going to end up with 10 over 15x minus 9 over 15x. Now we've got common denominator, so I can just put the whole thing over 15x. So we've got 10 minus 9. What is 10 minus 9? Congratulations, we've got 1 over 15x. That's it. Let's go back up and have a look at D. 1 over x take 4 minus 1 over x. You may think, miss, there's a minus in there, we can't do it. Surprise, we can. So we've got 1 over x minus 4 minus 1 over x. And it doesn't matter that this is minus or any of these are minus. We can do pluses the exact same way. Okay. What's the smallest thing that both x minus 4 and x go into? We can't know that. We don't know what x is, so we don't know what 4 less than x is. So what we're going to have to do, we're going to do this tricky thing. We're going to multiply them by each other. And just because the x minus 4 has a minus in it, but I want it to stay together, I'm going to use brackets. So just like with this one, we kind of ended up multiplying them by each other, well, without the x's. This one, we're going to multiply them by each other. Let's see what we get. Well, we've got on the bottom, x take 4 times x. Well, that's the same as x out the front of x take 4. I'm just rearranging it. I like to have just my x's on their own out the front of the brackets instead of after. It doesn't matter though. On the top, I've got 1 times x. This one, I've got x times x take 4. Don't forget we don't bother writing the times. And on the top, I've got 1 lot of x take 4. Now, this next bit's going to be a bit weird. Well, not really. I've still got my x minus, but because I'm subtracting the whole of this x take 4, when I'm subtracting it, I put brackets around it so that I don't forget that I'm actually going to subtract the whole lot, so I don't end up with, you'll see. So I've still got my x take 4 on the bottom. On the top, I've got x. Now, when I minus x, that's fine. Oh gosh, what happened there? That was the weirdest thing. Minus x is fine. Minus negative 4 becomes plus 4. And the reason I put brackets around was so that I didn't forget to change that to a plus 4. We've only got one step to go because we know x minus x, that just disappears. We end up with 4 over x take 4. That's the end, that's it. That's the video. That's adding and subtracting fractions. They may get more complicated. We'll be doing more complicated examples later. But the really only other way they get complicated is when you have to factorize, and then simplify.